first law of thermodynamics. Okay, so first law of thermodynamics, equation to Q equals to delta U plus W, right? Q refer to heat, delta U change in internal energy, and W work done. Okay, so unit Q delta U and W work done unit joule. Okay, scalar. Okay, so the heat Q supplied to a system is equal to the increase in the internal energy delta U, okay, of the system plus the work done W by the system on its surroundings. Okay, so this one is first law of thermodynamics. Okay, nice conversion. Okay, for Q, delta U, and W. Okay, so for Q, okay, we have positive, negative, and zero value, right? So positive Q, okay, our case here for positive Q, heat added or supply or flow into the system. Okay, for negative Q, okay, mean that heat remove, okay, release or flow out from the system. And Q0, I can know heat is transfer. Okay, so Q0 case for adiabatic, right? For case adiabatic, Q equals to 0. Okay, sign for delta U. So maybe positive or negative or 0. So positive delta U case the temperature increase, right? T final is greater than T initial. Okay, the negative value delta U negative. Okay, case temperature decrease. So mean that initial temperature is greater than final temperature. Okay, now for case temperature constant, okay, so delta U equals to 0. Temperature constant mean that final temperature equals to initial temperature. Okay, for delta U we use equation F2 and RT. Okay, F2 and RT. F here is degree of freedom. Okay, uh, F for mono, okay, monoatomic gas, F equals to 3, right? Okay, so F degree of freedom, okay, R here constant, gas constant, and T temperature. Okay, so the change in internal energy delta U equals to F2 and R delta T. Delta T here. Delta T is T final minus equals to T initial. So for case temperature constant, so it means that T final equals to T initial, so you get 0 here. So it means that delta U here akan equals to 0 for this case. Okay, so delta U 0, case the temperature constant. Okay, kalau T final is greater than T initial, so you get positive value here. Okay, so you get positive value for case temperature increase. Okay, then if temperature, final temperature decrease, okay, so you get negative value here. Okay, so temperature decrease, you get negative delta U. Okay. Okay, for W, we're done. Okay, so we have positive, negative, and also 0. So what done positive, what done by the system is if our case here is volume increase or gas expansion. Okay, volume increase. So what done should be positive value. Okay, and what done negative, volume decrease is the gas compression. Okay. So what done on the system negative, what done by the system positive. Okay. So if volume to increase, so what done is what done by the system. So positive value is uppercase is volume decrease. Okay, so mean that work done on the system. So you get work done negative. And work done zero is so work done zero, W0, okay, if volume constant. So volume constant mean that V final equals to V initial. So you get work done equals to 0. Okay. Okay, kalau V final is greater than V initial, so our case here is volume increase. So work done by the system positive value. Okay, if our case V initial is greater than V final, so volume decrease. So mean that work done on the system. So work done here zero, negative. Okay, so volume decrease. So work done negative. Okay, so ini case initially, and then first case here, okay, expansion. So work done by the system. So volume increase. Volume increase case ini. Work done by the system. So positive. Final volume is better than initial. Okay, so work done by the system. So positive. Second case here, okay, compress. So compress. So final volume to decrease. Ni initial, ni final. So final volume decrease. So it means that volume decrease. So work done on the system. So work done here is negative. Okay, negative. If initial and final volume dia equal, case ini, so work done here equals to 0. Okay, so work done equals to 0. Okay, so constant, volume constant, work done 0. Oh, saya tak buat ni. Okay, then thermodynamics process. Dia ada apa? 4 Okay, isothermal, isochoric, isobaric and adiabatic. Isothermal, constant temperature. Isochoric, constant volume. Isobaric, constant pressure. And adiabatic, okay, process go without or no heat transfer into or out of a system. So adiabatic process Q equals to 0. Okay, Q equals to 0. Okay, so isothermal here, okay, constant temperature, so delta U equals to 0, right? Use equation F equal to N R delta T. So T constant, so you get delta T 0. Okay, so delta U also equals to 0, isothermal. Okay, so delta U 0. Okay, so mean that Q here equals to W. Okay, dia equals to work done. Okay, and you can use for this equation for isothermal PV constant. So you can use P1, V1 equals to P2, P2. Okay. And then isochoric. Isochoric constant volume. Okay, constant volume. So constant volume, so work done equals to 0. So work done 0 from first law of thermodynamics. Okay, work done 0, so you get Q equals to delta U. Q equals to delta U. Q equals to the change of internal energy. So equal to U final minus U initial. Okay, energy added, heat Q remain in the system. Case heat kita tengok case kat sini isochoric. Okay, constant volume, right? Work done to 0. Okay, so maksudnya case kita maybe pressure increase or pressure decrease. Okay, pressure increase or decrease. Okay, so mean that kalau pressure decrease, okay, pressure decrease, so temperature akan jadi apa? Decrease juga, right? Okay, kena kaitkan dengan equation ya. Equation PB tu equals to nRT. Okay. Then isobaric. Okay, constant P pressure. Okay, so delta P 0. So W equals to P delta V. Okay, so semua ada value lah kat sini. Okay, so Q kita equals to delta U plus W. So W equals to P delta V. Okay, expansion isobaric. Expansion isobaric. So maksud dia apa? Volume increase, right? So work done positive. Okay. Kalau expand je, work done akan positif lah. Compress, work done akan negatif. Tak kira case yang mana, sama ada adiabatic, isobaric or isothermal. Okay. Kalau volume kita increase, okay, volume increase je, work done je should be positive. Okay, should be positive. Okay. So kalau volume decrease, so maksudnya dia compress. So sama ada case isothermal, isobaric or adiabatic. So work done dia negative. Kalau case compress or volume decrease. Okay. Okay, then adiabatic. Okay, adiabatic. Okay, Q akan equal to 0. Q 0, so you get delta U equals to negative W. Okay, delta U equals to negative W or W equals to negative delta U. Okay, so case this macam tadi juga, kalau volume increase, okay, so they expansion adiabatic, volume increase, so work done positive, work done on the system. Okay, kalau volume negative, okay, so compress, case dia compress, volume negative, volume decrease, volume decrease, compress, so work done negative. Okay. And then graph thermodynamic process. Okay, so graph sepatutnya tahu PV. Okay, so kalau refer to graph here, we have T1, T2, T3 and T4. So T4 is greater than T3 and T3 greater than T2 and T2 greater than T1. Okay, so maksudnya semakin ke atas semakin tinggi temperature-nya. Okay, case path AB, here is AB. AB here, okay, AB here is temperature T2. Okay, same temperature, point A to point B. So TA equals to TB equals to T2. Okay, and then arrow here, tengok arrow. Okay, arrow kita volume increase, right? From V1 to V3, so volume increase. So volume increase, so what done? Process AB isothermal, ni isothermal okay, AB, so what done there should be positive. Okay, why? Because volume tu increase. Okay. Okay, then process AC, here is AC, AC here is adiabatic. Okay, volume also increase here. Okay, so volume increase to adiabatic expansion, increase volume. Okay, so what done here should be positive for adiabatic expansion. Okay, then temperature here, TA is greater than TC. Okay, TA is greater than TC. Okay, tengok arrow je. Okay, initial point A and final point C. Then case AD, here is AD, constant volume. Volume equals to V1, constant volume. Okay, case kita constant volume is isochoric or isovolumetric. Okay, isochoric here. Okay, so case here is case pressure decrease. Okay, pressure kita decrease. So kalau isochoric, work done equals to 0. Okay, work done 0. Okay, and temperature here, TA is greater than TD. Okay, TA is greater than TD. Okay, then AE. Here is AE, constant pressure. Okay, isobaric. Okay, volume increase. Tengok arrow kita, volume increase. So kalau volume increase, work done positive value. Okay, work done positive. So case the isobaric expansion. Why? Because volume increase. So temperature here TE is greater than TA. TE is greater than TA. Okay. Yeah. Okay, graph. Okay, yang itu semua expand. Kalau arrow kita balikkan. Okay. Okay, kita ambil case BA. BA arrow from B to A. So case the volume here decrease. Case here, T here is T2. TA equals to TB equals to T2. Constant temperature. So case the isothermal. Okay, isothermal. Volume decrease, so compress. So isothermal compression. Okay, compression, isothermal. Okay. Okay, TA tu equals to TB equals to T2 and volume decrease. So work done here, kita calculate work done should be negative. Okay, why negative? Volume je decrease. So negative. Okay, then process CA, here is CA, adiabatic process. Volume je decrease. Okay, volume decrease. So what done should be negative. Volume decrease. Okay, then temperature here, TA here is greater than TC. TA is greater than TC. Okay, so case dekat sini adiabatic compression. Okay, then DA, here is DA. DA constant volume, but case here is pressure kita increase. Tengok arrow ni, increase pressure. Okay, and temperature TA is greater than TD. Okay, TA is greater than TD. Okay, then case EA, here is EA. So volume also decrease here. So volume decrease, so work done here should be negative. Okay, work done on the system, negative. Okay, so TE is greater than TA. Okay, TE is greater than TA. So constant pressure is isobaric. Isobaric. Case kita compress, so isobaric compression. Okay. Then thermodynamics work. Equation tu for isothermal, isobaric and isochoric. Isothermal equation what done je. Dia apa law right? This one. nRT ln V2 per V1 or nRT ln P1 per P2. So ln. Okay. So isothermal kena ingat equation ada ln Isobaric what done ni equals to P delta V. P times kan V2 minus V1. Isochoric the same equation dengan isochoric equation what done same equation dengan isobaric. Cuma V isochoric V constant right. So V constant here you get 0. So you get what done isochoric equals to 0. Okay, equals to 0. Isochoric what done 0. Okay, then graph. Ni graph tadi juga lah. Okay. Ini proses apa ni? Isothermal right. Tengok volume increase. So what done? Positive or negative?
Positive.
Positive. Okay. What done tu positive. Okay. So what done positive. Pressure kita volume increase. Okay, volume increase ni from 1 to 2 ikut arrow. Volume increase but pressure kita decrease right. Dan positive. Second case, isothermal tapi ni dia compress. Okay, compression, isothermal. Okay, so work done dia should be negative, right? Okay, volume kita decrease. Okay, volume decrease but pressure increase. Okay, so you get work done negative. Okay, then tu siapa? Okay, ni isobaric kan? Okay, isobaric. Okay, tengok arrow dia. Increase volume. So, kalau increase volume, so work done should be positive. Okay, so work done tu should be positive. Okay, constant pressure isobaric. Okay, next. Ini constant volume. Constant volume.
Isochoric.
Isochoric. Ini kenapa tak boleh buat? Okay. Isochoric. Tengok case dia, tengok arrow dia. Okay, dua-dua work done equals to 0. Okay, dua-dua work done 0. Tapi case yang kat atas tu case kita pressure increase. Okay, case yang ini pressure kita decrease. Okay. Case yang atas ni maksud dia apa? Temperature dia increase. P increase, temperature increase. Okay, case yang ini 1 to 2 yang ini case ini pressure decrease, temperature also decrease. Okay, so work done dua-dua 0 lah. Okay, dan case yang tadi isobaric tadi arrow tak nak arrow ni. Macam pula. Kita arrow cerita. Okay, so volume decrease, right? So volume decrease, work done je negative. Okay, work done negative. Okay, volume decrease. Okay, temperature boleh tengok sini. 1 and 2 here, temperature 1 is greater than temperature 2. Okay, tengok case. Okay, temperature, kita buat garis lengkung ni. Ini semakin ke atas, so temperature 1 is greater than temperature 2. Sama juga yang sini, 1 je, temperature 1 is greater than temperature 2. Okay. So sekarang dah habis. Itu je. Okay, so kita terus tutup. Okay, so number 1. What is your answer? Number 1. A, B, or B. Dia dah masuk ke tengok kejap ni. Okay. Dia dah masuk kan? Okay, ada lagi. Okay, so number 1. Answer dia apa? 1, A, B, C or D? Based on the first law of thermodynamics. What is first law of thermodynamics? First law of thermodynamics equals what? Q equals to?
Delta U plus what?
Yes. Q equals to delta U plus W done. So which following statement is correct? Which one?
C.
Tengok C, answer C. Ada yang lain. A,
Tengok
when
C juga.
C juga. Okay, kalau A, when the heat is out of the system. Kalau out of the system, Q kita should be positive or negative?
Negatif.
Negative, right? Dia kata positive, so out lah ini. Okay, then B, when the piston is being compressed. Kalau compressed, volume decrease, right? Volume decrease. Kalau decrease, word W kita should be negative, right? Work done on the system. Betul? Work done on the system. Kalau by the system positive. So sini salah. Okay. Compress mesti negative. Work done on the system. Okay. Kalau by the system positive value. Okay. Okay. Then C, the change in internal energy is only depends on the change of temperature. Betul ke? From equation, delta U equals to F per 2 and R delta T. So mesti delta U directly proportional to delta T. Okay, so it depends only on the change of temperature. N and R constant lah, ikut the same gas. Okay. So the answer is C. Okay, tengok D. When the gas expand, so volume increase, right? Okay. Undergoes changing in volume, there is no work done. Ya ke?
Tak ada.
Kalau expand, work done tu positive, right? Work done positive, expand. Okay. No work done, volume mesti constant. Constant volume. Okay. So the best answer here is C. Okay. Let's see. Okay, then number 2. Number 2, what's the answer to? A, B, C or D?
Saya jawab D, madam.
D.
Saya pun.
D, donkey. Okay, kita tengok semua donkey ke? During an isothermal expansion. Okay, kalau isothermal expansion, so work done dia positive, right? Expand, so volume increase, right? So work done should be positive. Expand. Then the volume of gas change from V1 to V2. So V2 is better than V1. So what case dia expanded? Which of the statement below is true about this gas? Okay, A, the amount of work done is equal to W equals to P times V2 minus V1. Betul ke? Ini adalah case apa?
Isobaric.
Isobaric. Isobaric. Okay? Not isothermal. So out. Okay, then B, heat is lost from the gas. Ya ke? Betul ke? Case itu expand. Okay? Kalau expand macam mana? Equation kita Q equals to first law delta U plus W. Isothermal delta U equals to 0, right? Delta U 0. So it means that Q kita equals to work done. And work done itu positive. So it means that Q pun positive value. Expand, right? Positive. So kalau positive, kalau loss ni mesti apa? Negative, right? Dot? Negative. So out lah. Work done kita, Q kita equals to work done. Work done kita expand, work done itu should be positive. So out untuk B. Okay. Then C, internal energy of the gas increases. Internal energy ni what? Isothermal. Isothermal internal energy dia constant, right? Okay. So delta U dia 0. Okay. Delta U, the change of internal energy 0. So internal energy dia constant. Why constant? Sebab T kita constant. Okay, isothermal. So out ini. And then D, work done on the gas.
Madam.
Yeah. Untuk isothermal. Okay, work done je equals to ini lah. nRT ln V2 per V1 or nRT ln P1 per P2. So the best answer is D. Okay, so let's answer B. Okay, now number 3. Okay, what's the answer 3? A, B, C or D?
Jawab B.
B, ball. Okay, yang lain? Semua B,
B juga.
B juga. Okay, kita tengok kat sini. A mole of an either gas. So, N kita equals to 1 sini. It undergoes an isothermal process followed by an adiabatic process as shown in figure. Okay, this one is isothermal. Okay, FG is isothermal. Okay, isothermal. GH, tengok arrow tu GH is adiabatic, right? Adiabatic. Okay, which of the following statements is true about the changes in the state of the gas? Okay. Okay, so kalau case ni, kita tengok case FG here, isothermal, okay, volume dia increase or decrease? Volume here. Tengok arrow. Volume dia decrease, right? So volume decrease, case ini work done dia should be negative. Okay, why negative? Volume dia decrease. Right. And then case adiabatic here, volume tu increase, right? Ni expansion, adiabatic expansion ni. Volume increase. So area under the graph is work done. So work done dia should be, case adiabatic, work done should be positive. Why positive? Because volume ni increase. Right. Okay. And then temperature here, okay. Temperature point G equals to temperature point F. Okay, now adiabatic process, temperature G is greater than temperature H. Temperature H. Okay, so we nak to A, when the gas undergo change from F to G mana ni? Isothermal. No external work is done on the gas. No external work. Ya ke? Ada external work, right? Okay. Okay, done on the gas. Okay, work done dia is negative value, right? Okay, no work done, hanya case apa? Isochoric, right? So out lah untuk A. B, when the gas undergo change from F to G is isothermal, heat is lost from the gas, ya ke? Betul tak ni?
Betul.
Betul. You use equation what? First law. First law of thermodynamics, Q equals to delta U plus W, what? Isothermal delta U equals to 0. So you get Q equals to W. W here, case heater compress. Okay, volume decrease. So work done kita negative. So work done negative mean that Q, the value Q kita negative. So negative. So heat is not from the gas. So right. Okay. Sebab work done je negative compress. Okay. Let's see. When the gas undergo change from G to H is adiabatic. The internal energy of the gas is constant. Constant ke? Temperature kita, internal energy kita not constant, right? Why? Because temperature kita tak constant. Temperature Tg is greater than Th. So internal energy, U tu equation internal energy, U equals to F2 and RT, right? T final and T initial temperature berbeza. So mean that U not constant lah. Okay. So out into C. Okay. Then D, when the gas undergo change from G to H, adiabatic juga, its pressure is proportional to its volume. Okay. Pressure is proportional to volume. Ya ke? Tengok kat sini. Pressure case kita kat sini, volume increase. Okay, G to H. G to H, adiabatic, volume increase. But pressure kita, this one is
Decrease.
pressure. Pressure is decrease. Pressure decrease. Dimension kat sini, pressure is proportional to volume. Salah right? Okay. B kita inversely proportional to pressure. Pressure inversely proportional to volume, not directly proportional. Okay, so the best answer here is B. Okay, so answer is B. Okay. Okay, next structure. Okay, sketch graph. Sketch graph, so make sure sketch dengan betul lah. Okay, sketch graph PV. Okay, case isothermal expansion. So you kena ikut dia punya ni. Expansion, not compress. Expansion, isochoric, heat absorb. Okay, so mesti ikut. Okay. So dia isochoric, mesti dapat apa value dia kat sini, kena tahu. Isobaric, ni isochoric. Isobaric compress. Compress, so volume mesti decrease kan. Expand volume increase. Compress, volume decrease. Adiabatic expansion, so volume increase. Okay. So kena ikut tu. Okay, so kita refer to graph PV. So T4 is greater than T3, right? Greater than T3 greater than T2 and T2 greater than T1. Okay, so isothermal, okay, mana-mana, tapi arrow kita mesti menuju ke mana? Expand. Expand arrow kita mesti mana? Ke bawah. Tak kira awak ambil yang mana lain ni. Okay. So arrow mesti betul. Okay. So mesti increase volume. Increase volume. So arrow mesti increase volume. Tak boleh up. Up dia akan decrease, dia akan compress. So volume kita mesti increase. Why? Because isothermal expansion. They expand, so volume increase. So TA equals to TB, equals to T2. Okay, so initial position is point A. So here is P1, initial, and here is V1, initial volume. Okay, then P is final, P2 is final. Okay, then volume here, let's say V3, final volume. Okay, so that one is isothermal expansion. Then continue isochoric. Isochoric, okay, constant what? Volume. So straight, vertical, right? So arrow, up or down? Up or down?
Up middle.
Apa? Up or down?
Up.
Up. Down, up. Okay. Ni tanya T. Okay, so arrow tu up. Okay. Arrow kita up. Okay. Up. Why up? Heat absorb. Q kita mesti positive, right? Okay, from thermodynamic. First law thermodynamic, Q equals to delta U plus W, right? What done isochoric, what done equals to 0. So Q kita equals to delta U. So how to determine delta U positif? Delta U mesti positif baru dapat heat kita absorb, right? So delta U positif, temperature mesti increase. Kita tengok point increase. So temperature at point A is greater than point C. Right? So you get positive. So arrow should be upward, not downward. Okay? So you get here positive value. Okay? So we let TA is greater than TC. TA is greater than TC. Okay. TA is greater than TC. Okay, then isobaric compression. Isobaric mean that constant pressure, constant. Okay. So compress. So arrow to the left or to the right? Compress.
To the left.
To the left. Okay. Mesti to the left. Pressure kita mesti constant. Ini boleh lukis kat mana-mana lah. Okay, tak mention ni. Okay, asalkan tunjukkan dia compress. Okay, so volume point initial position is point D on graph here. Final is point A. So volume point D is V2. Okay, so volume point A is V1. So mean that volume ke decrease. Temperature D, point D is greater than temperature at point A. Okay. Okay, then adiabatic expand. Adiabatic expansion. So volume increase or decrease?
Increase.
Increase. So arrow kita ke mana? Downward or upward?
Downward.
Downward. Okay, sebab expand. So volume increase. So arrow adiabatic is downward. Okay. Jadi downward tak boleh up. Kalau up, dia adalah case compress. Okay. So arrow mesti downward. Okay, so temperature point A is greater than point E. Okay. So work done here, okay, expansion, work done should be positive. Kalau expand dia, work done positive. Okay. Boleh? Okay, expand je, work done should be positive. Kalau compress, let's say ni isobaric ni kan, isobaric compress ni, work done here is negative. Okay, negative work done ni. Okay, so ini number 1. Okay, terus lagi number 2. Okay, number 2. An ideal gas is compressed. Nampak ni, compress. Isothermal. Isothermal. Kalau isothermal, value apa kita tahu? Delta U, right? Delta U should be 0, right?
0.
Isothermal. Then compress. Kalau compress, what done should be positive or negative?
Negative.
Negative. Negative. Okay. 36 joule work. Okay, so 36 joule ni should be negative. Why negative? Compress. So negative 36 joule. Okay, so how much heat flows from the gas during the compression process? So you use what? First law, right? First law. Q equals to delta U plus W. Delta U 0. So you mean that Q kita equals to W, right? Delta U kita 0. Negative, compress. Okay, delta U 0. So you get Q equals to W equals to negative 36 joule. Basic je kan? Okay, next, number 3. Number 3. Okay, an ideal gas absorb 1.5 kg of heat. Okay, so perkataan apa kat sini? Absorb So heat kita, this one is Q. So Q kita positive or negative?
Positive.
Positive. Positive 1.5 kilojoule. And expand. Here expand. Okay. So expand. So work done should be what? Positive.
Positive.
Kalau expand je work done je positive. Okay. So make sure ni kena tukar value, tukar unit SI unit, liter. Okay. So 1 liter equals to 1 times power of negative 3 meter cube ni 1 liter. Okay. Okay, under constant pressure, case kita constant pressure, so case isobaric isobaric. So boleh sketch graph walaupun tak suruh, boleh sketch graph. Okay, case kita hanya constant pressure macam ni, right? So arrow kita dimension guys tu what? Expand, right? So expand, volume increase. So arrow mesti to the right. To the right. Okay. Boleh. Okay, nyatakan volume ni. Okay. Volume jadi dalam liter is 20. Here is 35. Okay, so kalau convert to meter square, times power of negative 3 meter square. Okay, then pressure here, okay, P, okay. So now if kita nak apa, calculate the value of P. Value P ni berapa? Okay, calculate. Okay, we have Q. Okay, we have Q. So we can get equation. Kita boleh calculate dulu work done. Kalau calculate work done, isobaric work done kita W equals to P delta V, right? P delta V. Okay, so use equation P delta V. Okay, tapi work done kita tak ada value, right? Okay, P sebab P tak ada value. Delta V we have value. Okay, tapi kita tahu the change in internal energy is delta U. Delta U here 1050 joule. Positive or negative? Positive or negative?
Positive.
Why positive? Why positive? Macam mana boleh tahu positive value?
Sebab
Macam
gas
tahu?
absorb.
Okay. Kita tengok point kita kat sini, right? Semakin ke sini, temperature kita kat sini increase. Temperature yang sini dengan yang ini. So ini final temperature kita increase. Tengok arrow kita, case kita pun tadi expand, right? Expand, so temperature kita increase. Okay, temperature kita increase. Final temperature increase. Okay, so temperature increase, so it means that delta U should be positive. Okay, the change in internal energy, delta U the positive value. Okay, so delta U positive value. Okay, so delta U positive, not negative. But expand, temperature to increase. Okay, volume increase, temperature increase. Okay, sebab V kita directly pressure to T temperature. Okay, so we can use equation. Macam mana? Kita kena guna first law, right? First law of thermodynamics. Q equals to delta U plus W. Sebab we have delta U and Q. So we can determine W. Bila dapat W, so substitute into this equation. So you can determine P. Okay. Ni given value. Okay. Okay, so case isobaric. Okay, so you use first law of thermodynamics. Okay, so you can determine work done. Okay, then use W equals to P delta V. Okay, okay, P delta V. Okay, so measure volume in SI unit. Okay, siapa tak tukar tu SI unit akan salah nanti. Okay, so you can determine P. So you get 30,000 joule or 30 kilojoule. Okay. Okay, so kalau disuruh sketch kan, graph je hanya straight line tu je. Okay, buat case dia isobaric. Okay, constant P. Okay, next, number 4. Okay, number 4. We have 2 moles of a monoatomic ideal gas. So 2 moles. So here is N equals to 2. Mono degree of freedom equals to what?
3. 3.
Heated at constant volume. Constant volume. So kalau constant volume, work done equals to
0.
0. Work done 0. Okay, the amount of heat added is 4.5 times power of 3 joule. So heat kita positive, negative. Positive, negative?
Positive.
Positive. Okay, why positive?
Heat added.
Added positive. Okay, so Q itu positive. Okay, calculate the change in temperature. So the change in temperature is delta T. Calculate delta T. Okay. Okay, so you can use what equation? First law, right? Of thermodynamic. Q equals to, we have Q equals to delta U plus W. W 0, constant volume. Okay. W 0, constant volume. So you get Q equals to delta U. Okay. Tapi kita kan nak delta U, kita nak apa? Delta T. Okay. So use equation delta U equals to F2 and R delta T, right? Sebelum tu cuba kita sketch graph tu. Okay, kita boleh sketch graph. PV, case dia hanya constant. Volume, right? Constant volume, so straight line. Oh. Straight line, arrow itu up or down?
Up.
Up or why up? Why up? What kata up? Why up?
Temperature increase.
Why? Temperature increase. Okay. Macam mana tahu temperature increase? Bila dah calculate? Tak calculate boleh tahu tak? Okay, sebab equation kita tadi Q equals to delta U plus W, right? W itu 0. Okay, Q equals to delta U. Q itu positive, right? Q positive, it mean that delta U itu positive value. So, positive value mean that temperature itu increase. So, temperature increase mesti up. Okay, mesti up. Okay, temperature bawah ni, ini atas, temperature atas greater than temperature yang bawah. Okay, so arrow kita up. Okay, arrow kita up. Ni boleh label lah, ini volume diberi 3.5 0. Okay, unit itu meter cube. Okay, ni P ada value, tak ada value kat sini. Okay, nak cari value boleh dicari. Okay, so kita terus dapat. Okay, ada value yang diberi ni. Okay, dan juga degree of freedom ni. Okay, Isochoric, work done 0. Okay, so you can determine delta U equals to Q. Okay, delta U equals to Q. Okay, So delta U equals to F3, F2 kan. F2 kan. F2. Okay, F2 and of T. Okay, so after degree of freedom, gas mono, F equals to 3. Okay, so F equals to 3. Okay, so you can determine delta T, the change in temperature. Okay, so the change of temperature here may be unit Kelvin or degree Celsius. Okay, sebab dapat the same answer kali. Okay, so answer sampai buat degree Celsius atau Kelvin, dua-dua boleh terima. Okay. Okay.
Okay, madam.
Okay, then number 5, 7. It's the number 5. Number 5, okay. Okay, nak rehat dulu.
Teruskan je, madam.
Kita teruskan je. Okay, kita tengok 5. Okay, number 5, a system undergoes 2 steps of thermodynamic process. First step, internal energy of the system increases by 3 to 8 joule. Okay, so internal energy tu increase. So maksudnya delta U tu positive, right? Okay, so delta U positive. Positive delta U. Okay, when 150 joule of work is done by the system. So work done here positive or negative? Positive, negative?
Positive.
Positive. Okay, so delta U positive, work done positive. So from step 1 here, first step here, okay, so you can calculate Q, right? The Q equals to delta U plus W, right? Okay, second step, internal energy of the system decrease. Okay, decrease. So U decrease, U final is less than U initial. So it means that delta U negative, right? Decrease. Okay. When 180 joule of work is done on the system. On the system. So work done positive, negative?
Negative.
Negative. Negative. Okay. So calculate the total heat. Okay. So maksudnya kita kena calculate untuk dua-dua case. Okay. Dua-dua case lah. Okay. So calculate untuk case 1. First step. Then calculate untuk second step. Dan totalkan. Tambahkan je. Okay. Okay. So first kita just use that first law thermodynamic, right? Okay. First law thermodynamic. Okay, yang ini given value untuk first step. Okay, positive value delta U and W. Okay, then use first law thermodynamic. So you can determine Q. Q the positive, right? 4, 7, 8 joule. Okay, then second step, value to negative delta U and negative work done. Okay, so use equation, first law thermodynamic. So you can determine Q. So you get negative 3 is equal to joule. Okay, you get negative. So now calculate the total heat. So kita totalkan dua-dua tu. Plus kan. Okay. So you get 176 joule. Okay, 176 joule. Okay. number 6, we have 3 moles of monoatomic gas. So 3 N equals to 3. Then monoatomic gas. So so F the degree of freedom equals to 3 with initial pressure. So P initial 3 times power of 5 Pascal, where expanded isothermally, and then isothermally. So isothermal. So isothermal, that means that delta U itu must equal to 0, right? Isothermal. So expand, so increase. So kalau work done je equals to what? Expand, so positive work done, right? So they increase from 0.04 meter cube volume to 0.1 meter cube. So this one is initial volume and this one is final. So you know that work done here must be positive, right? Why? Because expanded. So work done positive value. Then the gas is heated at constant volume. Constant volume, so
Isochoric.
isochoric is a constant volume. Isochoric, so means that work done here equals to 0, right? Constant volume. To the new temperature. So saya buka dulu. To a new temperature. The new T. And finally go back to its initial state at constant P. So ada 3 cases here. First, isothermal. Second, isochoric. And then isobaric. Isobaric. Kenapa Natal ni? Okay ke?
Okay, madam.
Okay. Then A, the next sketch and label. Sketch and label completely. PV graph. So mesti complete label. So you can determine values step. First step isothermal. We need what? V initial, V final. We have V initial and V final. And then we have P initial. Isothermal. Then P final. So must calculate P final for isothermal. So isothermal. So we need what? P initial, P final. V initial and V final, and also T. T, isothermal, so T, constant T. So we have V initial, V final, and P initial. So we don't have P final and T, temperature. So must calculate. So first isothermal, kita kena calculate final pressure and T, temperature. Then volume, constant volume, isochoric. Isochoric. Initial, constant volume. Constant volume here continue from final volume here. Okay, so mean that V isochoric is V final. V here, the same V. Okay, isochoric. So isochoric here heated. Okay, so to see determine we have T initial and T final. Calculate T initial and T final. T initial is T here. T isothermal punya T. Okay. Then T final you must calculate T final. Okay, for isochoric. Okay. Isochoric, so you must determine T final. Okay. Then how about P? P initial and P final for isochoric. So you must determine P initial and P final. Okay, P initial and P final. P initial, okay. P initial is kita continue from final isothermal. Okay, so P initial is P final for case isothermal. And then calculate P final. So for isochoric, okay, kita mesti calculate P final and P final. Okay. Then case constant pressure isobaric. Okay, isobaric. Isobaric. Isobaric to continue. Okay, so we have B final, B initial. B initial is B final for this case. B equals only lah. Okay, B initial. Then determine B final. B final, dikata apa? Finally go back to initial state. So B final here is B initial for case isothermal. Okay. Okay, then so calculate then coming back, finally go back. So masa dia T final, you have T initial and T final. T initial is T from isochoric process. T final ni. So T initial. And T final here, okay, go back to initial, right? To T final here is T from isothermal. Okay. Panjang cerita tu. Okay, so case ni, we have three cases. Isothermal, okay, isochoric and isobaric. Okay, so tengok step by step. Okay, so calculate value for case isothermal. So given value here, we have 3 moles and F degree of freedom 3 for gas mono. Okay, so case isothermal. Okay, so given value we have B initial, B initial and B final. Okay, so and delta U must equal to 0, right? So you can determine here P final. Okay, so note set sini, right? Okay, P final kita nak calculate P final. Sekejap, sini. Tak mana ni? Okay, so now kita nak calculate P final. Okay, so use PB, P initial, B initial equal to P final, B final. So we have value here, so you can determine P final. Okay, so measure SI unit. Okay, so you can determine P final. Get P final 1.2 times the power of 5 Pascal. Okay. Okay, so we have P final, then temperature T. Okay, so calculate T. From equation here, so you can calculate T. PV equals to nRT, right? Okay, PV equals to nRT. Okay, so okay, kita boleh guna initial or final. Boleh equal je. Okay, so you can use initial PV equals to nRT. Okay, because initial or final case the isothermal, so you get the same T, same temperature. So you calculate now T for process isothermal. Okay, process isothermal. So now kat sini saya ambil initial. Siapa nak ambil final pun okay. Okay, so determine T. R here, gas constant is 8.31 8.31 and N mole kita 3 mole. Okay, now substitute P initial and B initial. Okay, so you can determine T. T here unit Kelvin. Okay, so you get 481.35 Kelvin. So complete for process isothermal. Okay, boleh faham tak? Okay, so now to complete the case isothermal, we have P initial, P final, V initial, V final, and T temperature. Okay. Okay, now second case is isochoric constant volume. Okay, so value for isochoric we have value. We have initial. Okay, kita continue from isothermal. Okay, kita continue from isothermal. So mean that initial volume for isochoric is final volume for final volume is isothermal. Okay. Okay, and then P initial is P final. Ni nampak dah yang saya tulis tadi. Okay. So dia continue. Dia start isothermal then continue dengan constant volume. Isochoric. Continue dengan isochoric. Okay. Then stop isochoric. Dah habis isochoric then continue dengan isobaric. Okay. So it means that P initial for case isochoric is P final for case isothermal. Okay. Isothermal. Okay. Then P final. Okay. P final. Why P final? Mana case dia? To the new temperature and finally go back to initial state at constant pressure. Okay. So maksud dia kembali ke finally go back to its initial state. Okay. So from initial tadi, so kita use pergi ke kembali pada initial case isothermal. Okay, so finally 3 times power of 5 Pascal from case isothermal. Okay, go back to initial state. Okay, P final and then volume. Okay, volume because ni isochoric right, same volume. See, kita continue volume, final volume, isothermal. Okay, isothermal ni final. This one is volume for isochoric. Okay, kita continue. Okay, now okay we have V and then T. P we have P initial and P final and then T. T initial is T here. Kita start from continue dengan isothermal. So this one is the initial. Okay, so this one is the initial. Then T final, calculate T final. Okay, so T final we can use equation PV equals to nRT. Okay, nRT. Okay, V the constant, K is the constant volume. Okay. So kalau kita nak determine final, okay, ini kita nak determine T final. So this one is final. P here is B final. Okay. So substitute value. So you can determine T final. T initial this one. So tambah sikit lah. T initial. Okay, for this case is 481 ya. 0.35 Kelvin. Okay. Okay. Boleh? Nampak complicated. So kena buat step. Okay. Step by step. Starting from isothermal lah. Okay. Then continue. Isochoric. Then lastly constant pressure isobaric. Okay. Isobaric and go back to initial state. So value B initial, B final, T initial, T final, complete. Dah ada. Okay. Then kita continue. Ini value. Okay. Kita write again value yang kita calculate tadi. Okay. P initial, B final, P final for case isothermal. Okay. So complete isothermal process. Value ni kita nak sketch graph PV PV graph. Okay, then isochoric kita calculate tadi. P initial, okay, P initial P final from case isothermal, dan P final equals initial. Okay, sebab dia pergi semula. Okay, so P final. Then volume, constant volume here equals to final volume isothermal. Continue from isothermal. Okay. Then initial temperature and final. Okay. Initial and final. Okay. So complete value for case isochoric. Then isobaric. Okay. Compress. So compress, so volume decrease. Okay. Volume decrease, so what done should be negative. Right? So volume decrease, volume starting here from 0.1. Okay. So this one is initial volume. Then final volume. Okay. To initial point. Okay. So this one is final volume 0.04. Okay. So initial and then final. Okay. And then temperature. Okay. The same temperature. Starting temperature is final temperature here. This one is initial temperature for case isobaric. Okay. And then final temperature coming back for one to original. Okay. And then pressure just stop for isochoric. Pressure itu 3 times power 5. So continue ni. So this one is pressure kita. Okay, so pressure here is constant lah. Okay, isobaric. Okay, so initial, final temperature for case isochoric is initial temperature for case isobaric. So final temperature is initial yang asal ni lah 481. Okay, 0.35 Kelvin. Okay, so this value ni mesti ada pada graph. Okay, complete. Okay, complete mesti ada pada graph. Okay, so sketch graph PV. Okay, so complete. Okay, so kita start. Okay, expanded isothermally. So volume increase. This starting A to B. Volume increase. Volume initial is 0.04 here. Initial 0.04. So here is 0.04 meter cube. Then final point B here is 0.1. Okay. And P initial here is P initial. Initial P is 3 times the power of 5. Okay. Then final at point B here is 1.2 here. Okay, so here temperature here, this line AB here is 481.35 Kelvin. Okay, so TA equals to TB. TA equals to TB ya. Okay, so equals to 481.35 Kelvin. Okay, then continue to isochoric. Okay, heated. Okay, so mass temperature mesti increase, so upward. Continue from isothermal je. Okay, continue. Okay, so heated. Okay, so isochoric. Okay, constant volume. Okay, so temperature is going to increase. Increase to, kita calculate tadi, increase to final year is 1203.37 K. So TC is 1203.37 Kelvin. Okay. So initial pressure, this one is initial. Initial pressure case ini. Point B, initial pressure is 1.2. Okay, is final pressure untuk case isothermal. Okay. Then final P, point C here, okay, equals to 3 times power of 5. Okay, 3 times power of 5. Okay. Then, okay, complete here. Okay, complete here. Temperature A is 481. Okay, so temperature C 1203 lah, 0.37 Kelvin. Okay, then continue isobaric. Isobaric, then kembali to initial point. Return to initial point. So temperature A and C here, temperature C is greater than A. Case kita compress. So volume dia decrease. Okay, from 0.1 to 0.04. Okay, so decrease. Okay, so complete cycle ni. Okay, so complete cycle A, B, C, A. Okay, A, B, C, A. Okay.
Madam, kalau yang ABC tu kita letak mana-mana je boleh kan?
Boleh. Letak kat mana? Maksudnya proses mana-mana.
Maksudnya macam A kat tempat C, C kat tempat A macam tu.
Asalkan betul awak punya value ni. Value ni kena betul. Kalau awak nak label, tapi starting kita A is isothermal. Tak mungkin A starting awak nak letak pada isobaric or isochoric. Ya, tengok ayat kita start from isothermal. So starting kita is initial point for isothermal here. Memang di sini pointnya.
Okay. Jadi kiranya yang macam ABC di label tu dia represent step yang kita buat tu yang daripada isothermal macam tu madam.
Dia start pada ayat dia yang diberi, start from isothermal. So point A is initial starting point. Starting point, so kat situ initial volume dan kat point tu juga initial pressure. Okay, at this point. Mesti initial untuk case isothermal, point A. Hujung dia is point B, final case untuk isothermal, masih isothermal. Okay, masih isothermal.
Okay madam.
Okay, then continue tak boleh terus continue isobaric. Mesti continue isochoric. Okay, Tak mungkin di sini awak akan wujudkan isobaric dulu. Tak boleh. Ikut dia punya ayat tu, step dia isothermal dan isochoric dan baru isobaric. Okay? Tak nak, dia punya point memang macam ni. Dia tak akan berbeza. Okay? Sebab kita calculate step isothermal. Okay? First step isothermal, so initial position isothermal dan final position isothermal. Okay.
Okay, madam.
Then continue isochoric. Initial dia, sebenarnya initial dia kita tak perlu calculate sebab dah wujud pada final isothermal. Kita hanya perlu calculate final dia. Okay, kita kena calculate final. Okay, maksudnya kita calculate apa? P final pun tak perlu calculate sebab dia kata kembali ke point value yang asal, right? So dia kembali tu 3 times power of 5 Pascal. Tapi temperature final wajib calculate. Okay, wajib calculate. Temperature final mesti increase sebab case dia di heat, right? Temperature mesti increase. Case 3, isobaric, dia dah kembali ke asas, so value-value semua dah ada, tak perlu calculate lah. Okay, dia ambil value final isochoric punya case dan dia ambil value isothermal initial value untuk isothermal. Okay, so graph point ni memang start dia memang A di sini lah. Okay, kalau nak label 1, 2, 3 pun okay. Tapi 1 awak mesti pada initial isothermal. Okay, point 2 is final isothermal. Or N initial isochoric. Okay, point 3 or C here is final isochoric. Or initial, bukan or N initial isobaric. Okay, so final isobaric is initial isothermal. Okay, then okay, next calculate the total heat. Okay, involved for the whole cycle. So kita nak heat, so kita determine QAB, QAC, and QCA. Okay, so nak calculate the total heat. Okay, involved for the whole cycle. Okay, so calculate Q here, QAB. Okay, then calculate QBC and calculate QCA. Okay, ikut dia punya cycle ni. Okay, so case isothermal, here isothermal, the delta U. Okay, delta U is equal to 0, right? Okay, delta U 0. So it means that Q dia, QAB here equals to WAB, right? Equals to work done. Okay, so work done case kita isothermal. Okay, isothermal, so we use equation work done here equals to what? Isothermal. Okay, isothermal Q equals to delta U plus W, right? So delta U itu 0 isothermal. That means that Q kita equals to work done. Case isothermal, equation work done equals to what? N RT ln, right? We have P, we have V. So boleh guna mana-mana lah. Ini V final per V initial. Or P initial per P final. So you can determine process isothermal QAB here. Okay, and then QBC. Okay, QBC pun sama, use the same equation. QBC pula work done dia equals to 0. W plus 0. Iso what? Isochoric. Okay, Q equals to delta U plus W. W tu work done 0. So it means that Q isochoric equals to delta U. Okay, so isochoric here is BC. So how to determine delta U? Okay, how to determine delta U? So use equation what? Delta U. F betul. Okay, F betul and delta T, right? So T final is 1203.37 minus 481 0.35 Kelvin. Okay, so you can determine and degree of freedom is 3, right? Mono at 3. So you can determine isochoric process for Q. Okay, hit this. And then QCA, isobaric. Okay, isobaric. So use the same equation. Delta U plus work done. So kena calculate work done. Okay, and delta U. Delta U use the same equation. Okay. So kat sini, kita punya work done here compress, right? So work done here should be negative, right? And delta U T final less than T initial, right? So delta U also you get negative. Use the same equation. F betul and R delta T. Okay. So you get negative. So you get answer here for QCA here is negative. And total kan? Okay. So you can total. Boleh? Okay. Kita tengok kat sini. Saya buat proses isothermal. Delta U0. So delta U. So delta U. So you get Q equals to work done. Okay. So work done case isothermal. Jangan guna P delta B. Okay. So guna N epsilon. Okay. B final per B initial or P initial per P final. So you can make 2A AB here. Okay. So here is AB. Okay, 995.54 joule. Okay, this one is for isothermal. And then second K, isochoric. Okay, isochoric. Okay, what done to 0. Okay, so use first law of thermodynamics. So what done 0, so you get Q equals to delta U. Okay, then calculate. Use equation F equal to and R delta T. F equals to 3 mono and R 8.31 and N kita 3 Okay, 3 moles. Okay, and delta T final minus initial. So you get positive. Okay, why positive? Heated. So maksudnya temperature tu increase final temperature is greater than initial temperature. So you can determine Q here is QBC, right? QBC here. 26,999.94 joule. Okay, QBC. And then case isobaric. Okay, isobaric. Compress. So maksud work done and delta U here equals to negative value, right? Okay, so kita calculate. Use equation. Okay, delta U equation is same equation F per 2 and R delta T. Final minus initial. Okay, so case the compress. Final dia less than initial. Okay, so you get negative here and also negative here. Okay, what done here equals to P delta V. A delta B. B final minus initial. Final kita less than initial value. Okay, so you get negative. Okay, so your answer is negative 44,999.94 joule. Okay, then totalkan. This one is QC, CA, CA. Okay, CA. Then total heat QAB plus QBC plus QCA. Saya buat 1, 2, 3. Okay, so buat sini AB. Okay, BC and CA. So you get negative 7,000 and 4.46 joule. Okay. Okay. So masuk di graph. Wajib betul label ni. Okay. Nama je sketch, tapi sketch je mesti point-point. V, P, initial and volume, T. Okay, mesti complete. Okay. Okay, then last number 7. Okay. Next Okay, number 7. Okay, I ada guess Okay, the condition of the gas change from A to B. Here is A and here is B. Okay, the 10.5 kilojoule of heat is added to the system. Okay, so maksudnya Q tu positive right? Added ni. Okay, positive. Positive what? 10.5 kilojoule for process AB. Okay, process AB. Expand. Okay. So Q tu positive. Okay, when the gas in condition B change to condition C, B to C here, okay, there is a heat added juga 3.2. So positive Q. Positive 3.2 kilojoule. Okay, so this one is process AB. Process AB, QAB equals to positive 10.5 kilojoule. Okay, then process BC positive 3.2 kilojoule. Okay, then refer to figure 2 here. Okay, so here AB here is process what? Isobaric, right? Okay, constant pressure. Pressure dia equals to 150 kilo Pascal. Okay, so initial volume for case isobaric here is 2 times power negative 2 meter cube and final volume is 4 times power negative 2 meter cube. And then for case isochoric, this one is isochoric, constant volume. Okay, so this one is initial pressure 150, finally increase to 300 kilopascal. Okay. So point here, temperature here. Okay, the same temperature. Okay. And temperature point C is better than temperature point C and B and D and B. Okay, ini temperature C and here temperature D and B. And here is temperature A. Okay, ini temperature A. Okay. So temperature D equals to temperature B. Temperature C is greater than temperature D. D or B. Okay. D or B. And then temperature D is greater than temperature A. Okay. Okay. Then A, calculate the work done in the process A, B, C. A, B, C. So work done, how to calculate work done? Here is isobaric. Okay. So work done for isobaric. Okay. Work done isobaric equals to, isobaric is AB equals to P delta V. Okay. So use P delta V. P here is 150 kilopascal and delta V final kita 4 times 4 negative 2 minus 2 times 4 negative 2. So you can determine work done AB. Work done BC, BC here, work done ni equals to 0, right? Isochoric. Okay, 0. So kita totalkan, so you get work done ABC. Ini AB, proses AB. Expand, isochoric kita increase temperature. Okay, ni increase temperature lah. Ke atas side, increase temperature. And increase pressure juga. Okay, so first kita ambil AB. Okay, P delta V, so calculate work done AB. So you get here 3000 ini work done AB. Okay, process isobaric. Okay, now work done isochoric 0 lah. Okay, isochoric 0 work done. So total, okay, so total ABC, so you get 3000 lah. WBC is 0. Okay, so you get 3000 joule work done process ABC. Okay. And then B what? Calculate the change in the internal energy of the gas in the process ABC. The same process ABC. Okay. Now calculate change in internal energy. So determine delta U AB and delta U BC. Okay. So from process AB here we have work done. And also we have Q. Okay. We have Q and work done. So you can determine delta U. So use formula first law of thermodynamics. Okay, Q equals to delta U plus W. Okay. And BC we have Q and W work done is 0. So it means that delta U equals to Q, right? Okay, then kita plus je lah. Totalkan semua. So, the case AB, okay, we have Q positive and work done kita dah calculate tadi 3000. Okay, so you can determine delta U. Okay, we get 7500 joule. Here is process AB. Okay, then for process isochoric BC, okay, Q positive 3.2 kilojoule and work done 0. So you use the same equation, Q equals to delta U plus W, first law of thermodynamics. So you can determine delta U equals to Q equals to 3.2 times power of 3 joule. This one is BC. So, okay, the next process ABC. Okay, so UAB plus UBC. Okay, so you can determine delta UABC. Okay, delta UABC. Okay, we get 10,700 joule. Okay. Okay. Let's see what done in process ADC. ADC. Here is ADC. What done? What done here? 0, right? Isochoric. What done here? Use P delta V. Okay, so what done for isobaric? P delta V. Okay, for KC, isochoric AD. Then,
Madam.
here. Siapa?
Yang soalan B tadi kan?
Hmm.
Kan Madam cari internal energy untuk proses AB lepas tu baru BC kan?
Hmm.
Saya terus kira untuk untuk ABC terus tak boleh kan Madam?
Boleh je. Masuk
Jadi
terus.
Q sama dengan internal energy plus heat plus W. Lepas tu saya masukkan
Maksud dia orang letak terus dalam formula ni kan.
dalam tu je.
Sama je. Janji
Sama je
kira
kan?
kira benda yang
Okay.
sama. Cuma saya buat satu-satu benda masuk. Okay. Sama je.
Okay. Thank you Madam.
Okay. Okay, let's see what done Isochoric, what done 0. DC, isobaric, we use what done equals to P delta V. Okay, so proses tu kat sini proses kita increase volume. Okay, so what done here should be positive process DC. Okay, so what done should be positive. So you get 6,000 joule. Okay, then what done ADC, so you get 6,000 joule, right? Plus then AD 0, so you get 6,000 joule. Okay. Okay, and then last, the total amount of heat. Okay, transfer in the process ADC. Okay, ADC. So process ADC here. Dia nak apa kat situ? Q kan? Dia nak Q. QAD and QTC. Okay. What done? We have what done. Okay, 0 and 6,000 joule. So how to determine Q? Okay, so delta U. Macam mana dapat? Okay. Yang tadi we have delta U. So delta U proses tu tadi. Okay, D and C here, D and B here, same temperature, right? Okay, ni same temperature. So it means that process AD and process AB here, U je is equal. Delta U equals to F per 2 N R delta T, right? Okay. So delta T process to AB and AD, delta T di sama, equal. Okay, so mean that delta U AB equals to delta U AD. Okay, so the change of temperature is sama. N, R and F pun sama, constant value, right? Okay. Okay. And then delta U for case DC and BC here. Temperature dia pun sama. Okay. Delta T dia. Perubahan delta T. Just sama juga. Maksudnya delta U BC can equal to delta U dc. Okay. Delta UAB and BC kita dah ada di sini kan tadi. BC and AB. Okay. Kita dah ada kat sini. So kita use sini. Okay. So for D, process isochoric AB, this one, D isochoric. Okay, dan dia dah zero tadi kan. So UAD equals to UAB equals to 7,500 joule. Okay, then process DC, UDC equals to UBC, UDC kan? Ni UBC. Okay, ni UAD ni, UAD and UAB. Dan ni UDC and UBC. Ni DC Okay, BC and DC. Okay, DC tu. Equals to, BC tadi kita dah calculate 3.2 times power of 3 joule. So you can determine delta U ADC. Okay. ADC. So AD plus DC. So this one is DC Okay. So you get 10,700 joule. Okay. Tapi kita kan nak delta U, kita nak Q. Okay, so nak Q, so use what? First law thermodynamic lah. Q equals to delta U plus W. Okay, so kita nak ADC, kita direct je guna ADC. Work done pun kita dah dapat dari ADC, right? Okay, work done ADC tadi, substitute dia. UADC 10,700 joule. So you can determine QADC. We get 60,700 joule. Ini satu cara, macam-macam cara. Cara berbeza dengan saya. Okay, tapi boleh diterima. Rasakan betul konsep dia. Okay, boleh faham?